Okay, everybody. So yeah, I did this whole lecture on the potential effects of the sun on the warming of the atmosphere with the sound muted. And so for those of you who missed it, I am now sort of at double speed reconstructing it. And what we have here is the Earth and then two layers of the atmosphere, the upper atmosphere, and then divided by lines that you can't really see down is the lower atmosphere, which is the troposphere. And what I'm presenting is the possibility that some people say, which is that maybe the sun is the cause of the climate change that we're experiencing. That maybe, oh, I'm throwing bad markers away, maybe it is changes in the intensity of the sun which can be blamed for the heating, warming, and climate instability and things that we've seen. And so, is it maybe changes in the intensity of the sun's output, or is it maybe changes in the orbit of the Earth that bring us closer or farther that are causing this and that? So that's what we're sort of going to investigate here. And the first thing that I bring up is solar cycles, because the sun does indeed move on 24-year cycles of increasing and decreasing. Actually, I think it's 22 now that I've looked at it again. But again, none of the temperature changes or anything that we've seen is working on a cycle like that. There's really just nothing that goes along with that in the data. And so then there's this other thing called Milankovich cycles, in which the Earth changes its orbit from more ovoid to more elliptical. And so as the Earth is going around the sun, as we see here, the orbit is, I guess, slightly an oval as the way I've drawn it, or maybe I'm about to draw it getting more or less so. And that is what happens. And it happens over the course of, 100,000 years or more. For about 2 million years, Milankovitch cycles happened over the course of less time. I think it was 40,000 years, but and then and I think I'm about to write this down here. But these are, in fact, the causes of ice ages. As the orbit changes, the Earth, is going to become closer or farther from the sun, and that is going to affect it. And so, yes, so for a couple of million years, they were 40,000 years. Now they're 100,000 years. But again, we're in the downward stretch of a Milankovitch cycle as far as where we are temperature-wise. We're in the getting cooler part. And so it's not really something that we can say we're in the middle of as far as causing changes to the temperature that we're experiencing. If anything, it should be heading the other direction. So let's see here. I think I'm about to shift gears here in a second and start talking about another thing, which is the other piece of evidence that it really isn't sun-based warming that's happening here. And so what I'm drawing is the two layers of the atmosphere, and the idea that, well, if it was the sun causing the problem, that if it was increasing heat from the sun causing the problems, that we would see greater warming in the stratosphere than the troposphere, which is our lower levels of the atmosphere closer to the Earth. So we would see more warming in the upper atmosphere than the lower atmosphere, because that, if you think about it, just like something under a heat source, it's going to be heating from the top down. But it turns out that what we see is the opposite. I don't know what I'm drawing there, actually. I probably faint dots with the red marker, sorry. But what it shows, what the data show, is that the Earth is warming from the troposphere up. So it is surface level warming that is happening, that is spreading from the troposphere up into the atmosphere. And so none of this really represents a change in the sun that would cause anything like this. And so it appears that with that, I am done. Thank you very much for your attention. I am and have been Mr. Auerbach.